That is correct. So I would say close to the AP test, you should probably kind of try to like start memorizing some of the formulas, but I'll give you guidance on which ones you should spend. You may. Let me write you. Are you going to downstairs C Hall?
Oh, I'm not fantasy.
Huh?
Maybe I don't know.
Okay, I'm gonna send you to the one that's downstairs, and then if it's busy, that's okay, but just go to a different one. Yeah, that's fine. Yeah. No, I go next week.
Oh, I should try and like murder.
Yes. Oh, thank you. My bad. I'll type it in.
I almost fell. I wasn't being dramatic. It was me almost losing my life.
All right. Okay, plan is we'll do a couple of these together. Okay, and then I'll give you some time to work. So let's start, please, with number 3. Okay, take a look at number 3. Okay, you cannot do U substitution on number 3. You could try it, but it won't work. Okay, and the reason why is that your U that you would pick is probably the top, but then it's not inside anything. So if you have just one thing on the bottom, but multiple things on top, remember that you can rewrite that as x squared minus 1 and then divide them each by x separately. So basically you're thinking about that divide by x as a common denominator, and then you want to see what you can reduce. So in this case, if I have an x squared divided by an x, what is that the same as? Really, this is just an x minus 1 over x. And then I'm ready to do the antiderivative. Okay, remember, antiderivative, you add 1 to the power, then divide. So if it's an x, I'm going to add 1 to that. It's going to become what? X to the 2. And then I have to divide the 2 in the front, which makes it a 1/2. Okay, this guy is a special. What's the antiderivative of 1 over x? ln absolute value x. Okay, now notice that I'm putting this in brackets because in this case I have endpoints. Okay, if I didn't have endpoints, I would just put the plus c and I'd be done. Okay, so on the top, we're plugging in an e. On the bottom, we're going to plug in a 1. But then since I don't really have space to do it right here, I'm just going to kind of scooch down a little bit. So capital F of E would be 1/2 an E squared minus an ln of E. And then remember the plus C we don't really care about. Okay, what is the ln of E the same as? It is 1. Very good. So this is 1/2 E squared minus 1. Now, if you don't remember why, okay, ln and E basically cross each other out. But you have to leave something as a placeholder, so you leave a 1. Okay, now let's plug in 1 on the bottom. So I have 1/2, we're plugging into this guy. So it'd be a 1 squared minus the ln of 1. Okay, technically plus c, but we don't really care about that. And then what is the natural log of 1? It is 0. Okay, and really those are the only 2 ln's you should know. ln of E goes to 1, ln of 1 goes to 0. So that means really I just have 1/2 of 1. And then what do I do with those 2 endpoints? Subtract them. So it'd be 1/2 E squared minus 1 minus another 1/2. So it'd be minus what? Minus 1 minus another 1/2 would be 3 seconds. Very good. It'd be E. Okay. Because you'd combine these 2 terms. But remember, you're just subtracting that bottom. Okay. The other one we're going to do off this page is number 2. Okay, this entire front sheet, you should not be doing any U sub on. Okay, there's always some other rewrite that you can use to avoid it. So go up and take a look at number 2. Okay, we never covered the rules to integrate absolute value because you're just going to do it with a graph. What shape is an absolute value graph? It is a V. Which way does the -1 in the bars shift it? Left, right, up, down. To the right one. And then it's a V, we said. Okay, if I wanted to integrate from 0 to 8, remember that I'm going to shade the x-axis along that interval. So we'll say here's 0. I would shade all the way to 8. And then I would shade this in right here. So the question is, how much area, this is x equals 0, x equals 1, this is x equals 8. So the question is, how much area did I just shade in? Well, I noticed that they're both triangles, and right now I can already count the bases, but what I'm missing is the height of both those triangles. So remember, if this is an equation, I can find the y value just by plugging in the x to the equation. So if this is y equals absolute value x minus 1, let's just plug 0 into that to see how high it is. What is 0 minus 1? -1. And what's the absolute value of -1? Absolute 1. So this is 0, 1, which tells me that triangle is 1 high. Let's do the same thing for 8. I'm going to take my x equals 8, plug it in right here. What's 8 minus 1? And the absolute value of 7 is still 7. And then I can take those two areas, calculate them separately, add them together. So this one would be 1/2 base times height. My base is a 1, my height is a 1. 1/2 1 times 1 is 1/2. Okay, second triangle, count your base. How many units is it from 1 to 8? 7. How tall is it? 7. So then it'd be 1/2 7 times 7. 7 times 7 is 49, which means that's 49 halves. And then I would take those two areas, add them together. What's 1/2 plus 49 halves? 50 halves or 50 seconds, which is the same as 25. So it'd be answer D. Make sense? All right, turn the page. Okay, we're gonna hit a couple of these that do have U sub. Everything from number 5 on, you should be using U substitution. So we'll do one off the next page, maybe. Let's do number 7. Okay, what do you think you should choose as your U? 2x. If my U is a 2x, then remember I take the derivative and I call it du dx. What would the derivative of 2x be? Just a 2. Then remember I times my dx up, divide my 2 down. So a du divided by 2 is going to replace my dx. And then remember, I want to come over here to this and I want to rewrite it in terms of u. So my 3 sine 2x is now a 3 sine u. And then my dx gets replaced by what? Du over 2. And then remember, these numerical pieces, you can go ahead and divide those. Now, 3 won't divide evenly by 2, but I can just leave it as a 3/2. Okay, once you get to it totally rewritten, you're going to snow cone it. Okay, so remember, for the snow cone, derivatives are down, antiderivatives are up. So if I'm already at the top, where do I loop back around to? Well, the bottom would be negative cosine. So it'd be -3/2 cosine u plus c. And then I would just take my u, remember how it was a 2x, you would just put it back in that spot. So looking at your answers, which one is correct? Yeah, A, it should have a plus before the C. So you're picking A, but just put in a little plus here.
So if you do your use substitution, you don't have to multiply the 2x times 2 to the power.
Say that again.
So if you do substitution,
Uh-huh.
you don't take like 2x and multiply by 2 and multiply.
2x.
Like, change.
Oh, no, because that's for chain one. Yeah.
And that's the opposite of chain one.
Correct. All right, turn the page. Okay, we are going to do maybe 2 more. Take a look for me, please, at number 11 on the next page. Okay, what do you think you should pick as your U on number 11? Very good. Remember, it's got to be inside stuff, so I'm going to pick y squared plus 1. Okay, then du dy is the derivative of y squared plus 1, which is what? 2y. Then remember, my dy goes up, my 2y goes down. So a du over 2y is going to replace where my dy is. Okay, go ahead and do your rewrite. And remember, in this step, the only letter that should survive should be u's. You should never have any x's after this point and no y's. They should all cross out. So I had an integral with a y. This is my u now, so now it's the square root of u. And my dy is now a du over 2y. And then what's going to cross out? The y's. If that doesn't happen, something's wrong. In order for me to rewrite that, I'm going to pull my 2 to the front as a 1/2 because it's technically a 2 on the bottom. And then my u, what power can I apply to it if it's in a square root? U to the 1/2. Okay, let's do our power rule. I have a 1/2 power. I need to add 1 to that. So I'm going to do 1/2 plus 2/2. What's 1/2 plus 2/2? U to the 3/2. And then to divide by 3/2, I'm going to have to flip it and put a 2/3 in front. But I also already had a 1/2. So what's going to happen with the 1/2 and the 2/3? 2's are going to be gone and leave me with just a 1/3 u to the 3/2. Okay, technically there is a plus c in here, but remember, it always crosses out. So if you don't put it on the AP test, you won't be penalized as long as you're working with endpoints. Okay, from this point, this is very important. You have 2 choices. You can bring this back to y's and use the original endpoints, or you can just take your endpoints, plug them into u, and then not go back. So we're going to do the second. What was my original top endpoint? Then I'm going to take the square root of 8 and I'm going to plug them in to here. So if I plug in square root 8, that would be the square root of 8 squared plus 1. What's the square root of 8 squared? Plus 1. My new top endpoint is a 1. And then I'm never going to go back to the y squared plus 1. My bottom endpoint was originally a 0. Oh, are we good? Oh, wait, sorry. My bad. Yes. A plus 1 is 1. Okay, bottom is 0. So it'd be square root 0 squared plus 1. And square root 0 squared plus 1 is?
1.
Now, if you had a calculator, okay, obviously that would be really nice if you could just plug in the 3/2 power. Okay, the problem is that if you don't have a calculator, you don't have that option. So you need to be able to break this power down occasionally, okay, into the power and the root. So write down, this is the same as 1/3. Take your 9, plug it in. It's to the power of 3. And then the half on it means it's also square root. So a 3/2 power means you're gonna cube it and square root it, but the order doesn't matter. So to keep our numbers small, let's square root first. What is the square root of 9? 3. What is 3 cubed? So I have a third of 27. Okay, now I know that can divide, but just leave it. Okay, on the bottom, we're plugging in a 1. So I'm gonna have a third of 1 to the 3/2 power, but in my head, I know that 3 means I'm gonna cube it, and the square root comes from the 1/2. But then what's the square root of 1? 1, and 1 cubed is still 1. So I have a third of 1. Okay, then from here, remember, it's this minus that. So since they both have a third, what's 27 minus 1? Then it'd be 26 thirds. Does that make sense? Okay, so for the last step here, it'd be a third of 27 minus a third of 1. You could take the third out, and that'd be 27 minus 1, which is 26 thirds. Okay, probably you don't need to write out all those last steps, but just to make sure that you understand what's going on. Okay, so 26 thirds would be your answer. Questions on that? All right, we're gonna do one more off this page, and then you're gonna have some time to work. We're gonna do number 12. Okay, but before we do that, I need you to change the top to be a pi over 8. Okay, otherwise the problem ends up not really making sense. Okay, so first question, what will I choose as my u? 2 theta. My u is a 2 theta. What does that make du d theta? Derivative of 2 theta is just like 2x, the derivative is just 2. Then I know that a du over 2 is going to replace my d theta. Okay, remember, whatever this derivative is, it always just ends up under the du. Okay, let's rewrite it. So I have the integral of secant squared u, because remember, my 2 theta is a u now, and my d theta is now a du over 2. What can I do with the over 2 if I want to pull it to the front? So it's a 1/2 secant squared. And then this is one of the special rules that you should know off your sheet. Integral of secant squared goes back to. Okay. Don't forget your little brackets around it because we have endpoints. But then remember, unless you want to turn this back into a 2 theta, you can't use your original endpoints. You're going to have to plug them in, switch them over to u endpoints. So my u in this case is a 2 theta. Let's plug in the top endpoint, which we modified to be a pi over 8. Okay, so if I take my pi over 8 and I plug it in right here, now it'd be 2 pi over 8, which is the same as pi over 4. Okay, let's do the same thing for the bottom. I had a pi 12. But I have to plug it into the 2 pi, so now it's a 2 pi over 12, which is the same as pi 6. Okay, then we're going to take both of these endpoints. We're going to plug them into our equation, and then we're going to subtract. So let's plug in pi fourths first. I want a 1/2 of the tangent of pi fourths. And then on the bottom, I'm going to want a 1/2 of the tangent of pi 6. Okay, now, I know we did hand trig so long ago, but tangent is sine divided by cosine. So we're going to need to find them and then divide. Let's do pi fourths first. Which finger is your pi fourths? Middle. And then how many sine fingers do you have? 2 divided by 2. What happens when you divide 2 by 2? You're going to get 1. So this is a 1/2 of 1, which is really just Okay, now switch to your pipes. Now technically, let me be clear here. This is root 2 over 2 divided by root 2 over 2. But either way, when you divide two numbers that are the same, they can't. Okay, now switch to your pi 6 finger. So it's 0. This is pi 4ths. Which one's pi 6? Ring finger right here, right? Okay, sign on top for the division divided by cosine on bottom. Where are my sign fingers though on my hand? So it's 1/2 divided by cosine is the top fingers on my hand. How many top fingers? 3. So it's root 3 over 2. And then remember that when you're dividing fractions, you keep change flip. So the 1/2, I'm going to keep it the same. But the square root of 3 over 2, I'm going to flip it. So it's going to be a 2 over root 3. Then cross those 2's out. What's your answer? 1 over root 3. Now, is there anything else that we need to not forget about? That's the tan part. There was already a 1/2 in front of that. So just don't forget that really it's a 1 over 2 root 3. Okay, and then remember, if it's a 1 over 2 and a 1 over root 3, you just times straight across the top. So 1 times 1 stays a 1. 2 times root 3 is a 2 root 3. And then what do I do with these guys? Subtract. So your final answer would be 1/2 minus 1 over 2 root. Okay. Questions on that? All right. So I'm going to give you some time to work. Okay, remember, today we're not taking a test. We're replacing the test with working really hard today. So I'd like you to try to get all the way through number 14 done. Okay, work together, ask me for help, but by the end of class today, you should know how to do each step. Okay, and then we'll do a couple more examples here in a bit. Okay, so 1 through 14, do what you can. Y'all, we're about to move on to the next page and do a couple more examples. If it's just one thing on the bottom, okay, this is one thing on the top, multiple things on the bottom.
Are you seeing this?
Under a common numerator, common denominator, and then, right? But this one you do separate. Yes.
You giving us sunburn, bro. I know I'm like on. I do look second. I like giving him. We're so far. You don't have to turn around.
You know what I'm saying? And you had 1x to -2. So now they. I'm gonna have this right one more time. This is the minus 1. This done. So really put a negative 1 there. Plug in. You'll plug in a 2 on. Yes. All right, go ahead and turn for me, please. You beat him at what? Oh, did you do an arm wrestle? Oh, no, you're not the champion anymore? Oh, tragic.
I still need my 0.
Right, you need to email me, it's not me to forget. All right. All right, we're gonna do number 14.
I actually think my mom.
All right. Okay, so number 14, first thing that you should notice, okay, is that your dx is on the wrong side. So if it's on the bottom, I'm going to scratch it out, move it over here. Okay, then I'm ready to integrate on both sides. Okay, but what I notice is that my dy doesn't have anything over there with it. Then put a 1 as a placeholder so that it's not alone. Okay, then you're gonna have a sine x, cosine x cubed dx, integral. So I moved my dx over to be with all the other x stuff. And then I'm gonna integrate, but what's the integral of 1 if I'm on the y side? It'll go back to a regular y. And then on the other side, I'm gonna need u sub. Any guesses on what we should choose as our u? Cosine, because what's it inside? A cube, right? So my u is gonna be cosine x. What's my du dx? The derivative of cosine is negative sine. And then remember, I'm going to divide that under the du. So it's a du over negative sine x, replacing my dx. So rewrite this integral. My sine stays the same, but what happens to my cosine? It turns into a u cubed. And then my dx is going to turn into a du over minus sine x. What has to happen in this step? All the x stuff, so the signs have to cross out. And then if my negative is left over on the bottom, really, that's just a regular negative. So I have y equals the integral of negative u cubed du, and now we're going to power rule it. Add 1, what's the new power? A 4th. And then I have to divide by 4 on the negative in front. So it's a negative 1/4 plus c. And then because I don't have endpoints here, my final answer, I would just take my original cosine x and just pop it back into that spot right there and you'd be done. So your final answer would be y equals negative 1/4 cosine to the 4th x plus c. Okay, sorry that I had to write that so small. Okay, but it'd be negative 1/4 u to the 4th, and then you just swap your u back to a cosine. Okay, turn the page. Okay, the next page is kind of similar to the level 2s on last time's homework. We're gonna do number 17. Yes, on the next page. Okay, before we start, I want you to change the y of 1 is 0 to y of 1 is 1. Okay, go ahead and separate that for me on number 17.
Also, hey guys, the weather is fine. What do I? Oh, yes. I'm grabbing my hat.
For this one,
I
so you plug in.
trying to grab my hat.
So it would be a third ln u, so this would be a third ln 4.
Whatever
And then this one would go to a third ln of 1. But then what is the ln of 1? Remember that one? ln of 1 is goes to 0. ln of e goes to 2. So it's ln 1. But then because this is a 0, that whole thing's a 6. So it'd just be a third ln 4. Because you're minusing a 0 with it.
Wait, where is it? Don't bring it.
Alright. Okay, number 17. Okay, a little bit of just advice here. When you are moving the y, don't take extra numbers with it unless you have to. So if you brought the 18y to the bottom, just bring the y. Here's how come. Okay, if you bring the 18 to the other side, you're going to have to multiply by 18 to get rid of it later. So only move the stuff that has to move. So if it's a times y, I'm going to divide this y to the other side, I'm gonna multiply the dx up, but I'm gonna leave the 18 where it's at. So I have 18, 3x minus 7 squared dx. From here, we're gonna integrate. You need a pencil?
I broke my pencil.
I have an extra, no problem. Okay, from here, you're gonna do the integral of 1 over y. What is it? It's a special, ln y. And on the other side, what do I need? What does this side need? Okay, it needs u substitution. Okay, because it's not just an x squared, it's some x stuff together and then squared. So what would my u be on that right-hand side? 3x minus 7. That means that du dx is just a 3, which means that a du over 3 is going to replace my dx. So now we're ready to swap, guys, come on, pull together. Okay, so I have an 18 u squared du over 3. And then my 18, since I left it over there, now I have something to divide the 3 with, right? So 18 divided by 3 is how many? So this is a 6u squared. What's the antiderivative of 6u squared? 2u cubed plus c. And then remember, since I don't have endpoints, I'm going to take my original u stuff, pop it back into that spot. So I have the ln of y is equal to 2 3x minus 7 cubed plus c. Now remember, you really need to get this by itself, the y. So how do I get rid of the ln? E it. And then how will I get rid of the absolute value bars? Plus or minus. So it'll be plus or minus e to the 2 3x minus 7 cubed plus c. And then from here, we're going to take this and plug it in. Okay, remember, we changed our ordered pair to y1 equals 1. So we're putting a 1 in on this side. Well, we choose the plus or the minus. We want to match the y value we were given. So it's got to be a plus. And then if it's okay. Just leave it. So this is a 1. So 3 times 1 is 3, minus 7 is negative 4. And negative 4 cubed is negative 64. Okay, then from there, 2 times negative 64 is, do you know? Yes? Okay, from here, I still got to get to this c, but it has the e base. How do I undo the e? And what is the ln of 1 again? Okay, ln of 1 goes to a 0, which means what is my c if negative 128 plus c is 0? Add it across, it's a plus 1. Okay. So your final answer would be y equals positive e to the 2 3x minus 7 cubed plus 120. Yes, sure. You asked me that again, Benji. Where'd I get what?
Oh.
Oh, Dolly left her Hello Kitty. Can't be without your little kitty. Okay. Are y'all ready? Are you good? Okay.
So minus 12.
No, you threw my water bottle.
You took it best of me.
Because you threw my water.
We went to pencil. Yeah, we went to pencil.
Now? Okay. Nope. Okay. All right, turn the page.
Yeah. All right, so like, dude, I'm
You can give it back. I'll give it back.
It's fine, I got it last week.
Okay.
I'm not even looking at it.
Yeah.
Why do I feel like that's gonna be completely illegible?
I got it.
All right, good.
That's impressive. I'm kidding.
All right, turn the page, please. All right, we have about 20 minutes left. Okay, the next thing we need to review is average value. This is a formula. Does anyone happen to remember it? Yeah, it is. 1 over B minus A. All right. So write down your average value formula. Okay, and then for number 18, I want, okay, girls, are we ready? Okay, we're gonna set up average value, but it should be -1 to 4. Okay, so it says -1 to 2 here, but if you do it like that, you're not gonna get an answer choice. Okay, so -1 to 4. So let's set up our average value on that interval. It should be 1 over B minus A. This is my A, this is my B. So it should be what?
1 over 4 plus 1.
Okay, 1 over 4 minus -1. And then integral -1 to 4. Okay, and remember what this finds is the average y value of the graph on that interval. Okay, so 1 over 4 minus -1 is really a 4 plus 1, which is a fifth. And then how will you work this out if you have a graph? How would you do that integral if you have a graph? Calculate the area. Okay, which I'm trusting that you can do on your own. Okay, but you'll calculate that area. And then don't forget, area above the x-axis counts as positive, below counts as negative, and then at the end, you'll divide it by 5. Okay? But I'll leave that for you to do. Okay, go ahead and turn now to number 20. Okay, go ahead and type this into your y equals on your calculator. If you don't have one, I'll get you one. You need a calculator? Three. Okay, go ahead and type it in, please. Oh, yeah.
You called those now.
Oh, I did not.
Look at it.
Yeah,
Look at it.
Look at this one. You will go to fighting. Fighting.
No, but you didn't have the pencil because he drew on my phone. So it's your fault. You drew on my water bottle. Then he got mad at me for some reason. I'm drew on my water bottle. So then I took the pencil and it put my hand.
Oh, you have it?
Me somehow.
You have one right there?
My fault.
All right. Okay, let's try to lock in because we just have to do 4 more questions, but they're all in the calculator that they could go really quick. Okay, if you have velocity and you want the average velocity, that's the average value formula because you have the function that you want the average of. So write down the formula 1 over b minus a, but use these numbers. We're doing from -1 to 2. So average value would be 1/2 minus -1, interval -1 to 2. Okay, but I know it's average value because I have velocity and I want average velocity. That's the exact same thing. So in your calculator, you should have typed your equation into y equals. And then once you have it typed in, you should know how to put that into the calculator. Okay. So once you have it, I'll show you how to do it in case you forgot. But it's 1/2 minus -1. You could also just get that to get a 3 and then math 9. -1 to 2, alpha trace y1 dx. My answer came out as a fraction, but if I want to convert it, just math enter, and it'll turn it into a fraction for you. Okay, so 11/4 was the correct answer. Alpha trace for y1. Okay, now that is not the same for the next question. Notice that I still have velocity, but what are they asking me the average for? Okay, that means you're doing AROC. Okay, or average rate of change. And the reason you know it's a rate of change is because I'm going from velocity to acceleration. That's a slope. So in the calculator, you're going to do v of 2 minus v of -1 over 2 minus -1. There are only two averages, so you just have to figure out which one you're doing. Is it an average slope or an average y value? Okay, in the calculator, you'd set up your pretty fraction. Then remember, it's alpha trace y1 at 2 minus alpha trace at -1 over 2 minus -1. And you should get an 8. But there are only two average formulas that you need to know. It's either average value or average slope or rate of change. Okay? All right, last two questions we're going to do together. Last page. Okay, go to number 27. We're doing 27 and 28. They are? Look at me. Okay, put the equation into your calculator. You're yonder package. That boy. All right.
I don't know if it was still on the ground.
It's okay.
Well, your phone's right there, bro.
All right. Okay, both of these are going to be version B's, and if you don't know what I'm talking about, I want you to write it down. It's f of b equals f of a plus the integral from a to b. Now, I want to tell you why I know that this is the formula. Okay, this is giving me the degrees per minute that a coffee is cooling off after they take it off the kettle or whatever it is. Okay, so it tells me that it was brewed to 98 degrees. That would be your starting temperature. So I want the coffee at 5. I'm going to do T of 5. Okay, pretend that's like the temperature at 5. And then when do I know the temperature at if it just came out? That'd be the temperature at 0. And then I'm going to integrate from 0 to 5 on my function that they gave me in the calculator. Okay, one more thing I want to point out is your units. If this is degrees per minute, what do I get when I integrate it? Degrees, and that'd be the degrees it cooled off. So what was the initial temperature? 98. Then I'm going to figure out how many degrees it cooled in the calculator. And then that'll tell me my final answer. So put it in your calculator. Okay, we're gonna do 98 degrees plus math 9, 0 to 5 seconds, alpha trace y1. Okay, where this is your starting temp, and then this is how many physical degrees it would have cooled off, giving you a final answer of 89 degrees. Okay. We have one more like that, but I want you to set it up. So read through 28, and I want you to set up this. Okay, so in this case, I used a T for temperature. In 28, we're talking about people, so let's just call it P instead of T. I did. Are you talking about in my Y equals? Okay, so read through 28 and set up your version B like this. Are you talking about in the Y equals, Benji?
Yeah. How do you, enter, the Y1?
So push Y equals. And then I did the -3. E is on the second LN button. And then it was -0.24x. Oh, you mean to put it, it's alpha trace. All right. Okay, for this one, let's just try to lock in. We're almost done. Okay, when do I want to know how many people? If you read it, I want to know how many people at noon. And I know how many people there are when it opens. Okay, but what time does it open? Does the park open at 0? No, when does it open? Not till 9 a.m. Okay, so I want the number of people at 12. I know the number of people at 9, and then I'm going to have to integrate the function they gave me to bridge the gap. Now, one more question. What was E of T measured in, it says? People per hour. What happens when you integrate people per hour? You get a number of people. So this is all the people that came in, plus all the people that were already there. How many people were already there? 120 employees already present, plus, and then this would be all of the new people that come in that you need to do in the calculator. Okay, but you'll type that into your Y1, integrate it only 9 to 12, because you're not starting at 0, because the park doesn't open until 9, and then you'll add it to the 120 that we're already doing. Okay? This is due. Very seldom do I say a due date. This is due next class. Okay, you have time to finish it. Okay, but it's counting as a test grade, so we need to prioritize finishing it up, okay? If you need any help, let me know. That's a great question. I'm gonna send you a key with the correct answers circled, but I'm not gonna include all the work because some people just copy it from my list. So you should have the correct answers to check yourself, but it will be graded correctness, if that makes sense. Okay, yes.
Why does it say 9 to 12?
Because the park's open all the way till that'd be 11 p.m. But they're not asking us how many people are there at 11. They're asking us about time 12. That make sense? Yeah, that's right. And then round it up because it's people. So you couldn't have like 0.6 of a person.